So we will have some example of power series. Y prime is minus xy is equal to 0. So to solve this, we will use series solution where y is equal to summation of cn x raised to n from 0 to positive infinity, and y prime is equal to summation of derivative of this and cn x raised to n minus 1 from 1 to positive infinity. So we will just substitute summation of n cn x raised to n minus 1 from 1 to positive infinity minus x summation of cn x raised to n from 0 to positive infinity is equal to 0. So we will just distribute this x to this expression. So n cn x n minus 1 from 1 to positive infinity summation of n is equal to 0. cn x raised to n, add the exponent plus 1 is equal to 0. So our goal is to have pure x raised to n in every expression. So we will add 1 here to make it x raised to n and minus 1 here to make it x raised to n also. So as we subtract here, we will add some number here. So summation of n plus 1 cn plus 1 x raised to n from 0 to positive infinity minus summation of cn minus 1 x raised to n from 1 to positive infinity is equal to 0. So again, so our index is not the same. So we will make it the same initial point. So what we need to do is substitute 0 and add this expression. So where n is equal to 0, 0 plus 1, c1 plus 1, c0 plus 1, x raised to 0, plus this expression, n plus 1, cn plus 1, x raised to n. So when we simplify this, it will become c1 because 1 times c1 times 1 is c1 plus summation. This is from 1 to positive infinity. 1 to positive infinity. N plus 1, cn plus 1, x raised to n, minus summation of cn minus 1, x raised to n, from 1 to positive infinity. So we have x raised to n in both expression and an initial point of 1 in both expression. So what we need to do is factor it out. So c1 summation n plus 1, cn plus 1 minus cn minus 1, x raised to n is equal to 0. Since this term is not equal to 0 and this term is 0, c1, there's no constant in the right hand equation, and c1, we can say that c1 is equal to 0. So arranging this equation, n plus 1, cn plus 1 minus cn minus 1 is equal to 0. So arranging this, cn plus 1 is equal to cn minus 1 over n plus 1. So we will substitute value of n greater than or equal to 1. Value c1 plus 1 is 2. 1 minus 1 is 0 over 1 plus 1 is 2. N is equal to 2 plus 1 is 3. C3 is equal to 2 minus 1, C1, over 2 plus 1 is 3. But notice that our C1 is equal to 0. So we can say that this C1 over 3 is becomes n is equal to 3 C4 equal 3 minus 1 is 2 over 3 plus 1 is 4. But we have value of C2, so we will just substitute. It will become CO over 8. N is equal to 4. C5 is equal to 4 minus 1 is C3 over 4 plus 1 is 5. And our C3 is 0, so it will become 0. So N is equal to 4 to 5. C6 is equal to C4 over 5 plus 1 is 6. We have value of C4, which is CO over 8. CO over 8 times 6 is 48. We can say that Y from our equation CO plus C1x plus C2x squared plus C3x cubed plus C4x to the fourth plus C5x to the fifth plus C6x to the sixth plus and so on. It becomes CO plus C1x. Since we don't have value of this, we just copy plus C2, which is CO over 2 plus our C3 is 0 plus C4, which is C0 over 8 plus our C5 is 0 plus our C6 is 0 over 48 plus and so on. So our C1 is 0, so this term is 0 also. So simplifying it, y is equal to 0 plus 0x squared. This is x cubed, x to the fourth, x to the sixth. COX squared over 2 plus COX to the fourth over 8 plus COX to the sixth over 48 plus and so on. So let's factor it out. CO plus x squared over 2 plus x to the fourth over 8 plus x to the sixth over 48 plus and so on. So this can be expressed by CO from 1 to positive infinity of x raised to 2n over 2n n factorial. And this term is also equal to CO e raised to x squared over